Question 8, Financial Maths. Olga, Chen, Fiona and Rohan all have bank accounts. This looks like it's going to get messy with 4 people involved. Olga simply puts 3,000 in a savings account. 2% will be 0.02, so 0.024 is 2.4%. And it's every year, 5 years, correct to the nearest cent. So we just have 3,000 is invested 1 point at the interest rate 0.24 to the power of years, and that's going to give me the nearest cent when it comes out as 3377.699, so that's 70 cent. 3377 Olga has. Explain what is meant by present value of a payment of 1,000 in 1 year's time. Well, it's worth less now. So 1,000 in a year's time, well, let's say the interest rate's 5%. 5% interest is actually worth 1,000. This is its present value. So let's just make that a bit clearer. 1.05. So 1,000 divided by 1.05 is equal to 95238. So I would have to invest 95238 at 5% to get 1,000 in years time. So the present value of 1,000 is 95238. You could add to that as well if you wanted. Chen puts a different amount into a savings account at the same interest rate, and after 6 years Chen has this much. So we have the answer to what Chen has. 4,000. We don't know the amount, but he has invested at 1.024 to the power of 6. So the amount that he's invested is just 4,000. Just manipulation of the present value future value formula. 1.024 to the power of 6. I'm hoping you financial maths whizzes found this like an easy question. A is equal to 3469.446 on a calculator. Go back and check. Nearest cent 3469.45. First 3 parts are easy. Is that the doom of what's ahead? Fiona is taking out a loan, same interest again, and she's making payments quarterly 4 times a year. So if we had 2% interest and we wanted monthly payments, we do to the power of 1/12. So if we have 2.4% and we are making quarterly payments 4 times a year, we're making to the power of 4/12, or 4 times a year, be every 3 months. 1.024 to the power of a third 1/3 will give me 4 monthly payments. This works out to be 1.007936. A percentage, correct to 2 decimal places. Well, it's this will be 1%, so it's 0.79%. And if we imagine 3 times a year, 4 times a year, that will be 2.8%. Just above the 2.4 because of compounding. I'm just spotting a mistake here. It's every 3 months will be 3/12, and that will be 1/4. I hope you're all recognizing this so I don't have to go back and start again. Just double checking my answer. That 4 payments at 8% will be 3.2% again, just in a way of checking your answer to see you're right. That did sound too high, so I just went back and double checked, and in my rush to finish it I've made this mistake. So it's 4 payments a year, and that will give 1.0059 is what I was expecting. 5946. So that's approximately 0.6% 4 times a year, which would give the 2.4%. So it's always good to check to avoid mistakes. So this is 0.59%. 59%, just under the 0.6 because of compounding. Rohan wants to put the same amount of money into a savings account. We have 36 payments. So at the end of 3 years, so we have a series here that's going to add to 12,000. So what are we asked to do? Taking A as the amount that he's investing. So the first payment will be A by 1 point. 0.11 per month. We have 36 of these months. 0.11% is 0, then 1. So the first payment plus the second payment. Is he putting it in at the start of each month? So he's getting an interest payment at the end of each month. So 1 to the power 2, the first two terms and the last two terms, plus a by 1.0011 to the power 35, and then plus a 1.0011 to the power 36. All of them are equal to 12,000. So we have a sum of n payments here. S of n is equal to a times 1 minus r to the power of n over 1 minus r. A is our first payment. We could factor out a, but let's just leave it in as a times 1.0011. That's a by 1 minus, I have to multiply by this guy every time, the ratio, 1.0011 to the power of 36, and all divided by, you can reverse these around to make them positive if you want, but this is the way the formula is given, 1 minus 1.0011, and this a is 12,000. So I'm going to multiply 12,000 by the bottom. I'll write it as the negative, and then we just simplify the top in two parts and have our answer in a couple of lines. So that gives minus 13.2 is equal to a times. So this one by this one is giving me minus 0.0404 162.993. I think I can round off at that point, so a is going to be equal to, just divide the left by the right, and that gives a to be 326.6. I might have rounded off here, maybe a bit too early. It is nearest cent, but I'm getting 326.60 for the amount that you would have to invest. So if we just estimate here 36 months by 326.60, 36 months, if we multiply that by 36, we get 11,757. So that does look like it'll be 12,000 in the account at the end of 3 years. Tiny amount of interest applied. Here we have an expected value question coming in at Leaving Cert. The expected value of this is 1385, so we have a 52% chance of selling a child's ticket. So 0.52 times 11 plus, and we have x by 0.33, and then the middle one, €5 less than an adult ticket, so that's x minus 5 by 15% chance of selling those, and that expected value adds up to 1385. Strange question to throw in at this point, but let's simplify it down. So we're going to get 5.72 plus 0.33x plus 0.15x, and then minus 5/15 0.75 equals 1385. So we're going to get 0.48x is equal to 1385 plus 0.75 minus 572. So we divide all of this by 0.48. We'll have our answer for x. Just a little line there. So the expected value, we're not asked to find the expected value, we're asked to find x. So x is 888 divided by 0.48 is equal to 1850 for, what is that, the adult ticket, 1850. Does make sense on the basis of the question. 1850, 1350 and €11 makes some sense, and if you fill them back in you'll get the expected value. Then we have this question that was on the Junior Cert sample paper last year, markup and margin, a margin of 18%. So let me do this kind of a way where we're using 100 in the question. So the way I would teach third years, well, let's take that we sell for 100, and that makes it easy to work out the margin. The margin is the markup as a percentage of selling price, so to be 18%, let's say we buy for 80, just do it another way. buy for 80, sell for 100. And we have markup and margin. The markup here, well, the profit is 20, which comes into both of them. So percentage, markup profit as percentage of cost price, markup is going to be 20 over 80. And the margin is going to be 20 over the selling price, 100. So to get a margin of 18% will be 18 over 100, which means that we sold it for 100. And if we made 18 profit and sold for 100, we must have bought for 82, or 100 minus 20 gives this 80. 100 minus 18 gives this 82. So 82 divided by the profit. Sorry, the profit, the 18 profit divided by the purchase price. And let's just double check these. We purchase for 82 and sell for 18. Sorry, we purchase for 82 and sell at a profit of 18. We're selling for 100. And that works out then. The margin will be 18 over 100 and the markup will be 18 over 82. So 18 over 82 is going to be our answer here, which is 0.2195 or 22%. So kind of just a bit of a logical thought question here at the end of question 8, I believe.